the premise, or the sort of the initial question, and this was sort of in the teaser video and in the email that went out, is, you know, what do grades mean, right? This is like this weird cosmic question that we all struggle with. We've all, you know, we've been teaching for a long time, or maybe some of you haven't, but, you know, I'm going on, well, too many years. And, you know, don't you feel funny just like writing a number next to some student's name, and that's sort of the sum of what they are, and, you know, and it doesn't feel right. Or, so there's sort of the negative aspect. There's also sort of the false positive, where there's no way that student made an A in this class, right? Like you've talked to them, and somehow they managed to make an A in your class, and you go, they don't really know what they're doing. Yeah, that's the question, right? What does it mean to get an 85 on a test? You know, what does it mean? What do you think it means?
85% of the contents they've mastered.
Okay. So, okay, question mark, right. Does that mean that they got like most of the content 85% correct, whatever that means? It's like every question they got, if a question's worth 10 points, they got like 8 points on them, mostly, maybe. Or maybe it means that if there were, you know, 10 questions on the exam, they got 8 of them completely correct, and the other 2 they bombed or whatever, right? So, and that's an important distinction, by the way. Anybody who works in medicine knows that, right? If, you know, if a drug is 85% effective, what does that mean? You know, does it work 85%, you know, is it like randomly 85%, or does it work 100% of the time on 85% of the people, right? That's the question you want to know. So standards-based grading is a way to try to combat that. You know, let me tell you a little bit how calculus works here at UF. So one of my colleagues is here, so she knows the dirty secrets. But, you know, a big calculus class, like I'm teaching this semester, has a lot of things, a lot of padding built into it, right? There's clicker points for being there, and basically they get points for being there. Homework is not at all punitive. They can easily max out their homework grade. They have discussion 1 day a week with a TA. We give quizzes in there. You know, we drop 4 or 5 of them. So, you know, they can pretty easily max all that out. And you add all that up, and suddenly that's 25% of the grade that they could all max out, okay? And then the exams, well, you know, they're multiple choice, but there's also some free response. You get some partial credit. And before you know it, a student who really doesn't know the material all that well made a B, okay? And so this standards-based grading is really good for detecting false positives in that sense. In other words, it's difficult for a student to make a B without actually knowing enough material to earn a B, like actually earn the B. So, so the idea is and this takes thought, you know. I mean, especially after you've taught a course a few times where you're just kind of on autopilot with the thing, you know, and you're like, yeah, I know what to do, you know. And yeah, I know how to teach calculus. That's no problem. You know, you give me a topic, I'm walking to the room, I'll have a lecture in my head by the time I'm there, and everybody's like that with their own introductory courses that they've taught so many times. But then you really have to stop and think about it. Okay, what do I teach in this course that's completely fundamental, right? In other words, what should students be able to demonstrate to me that they have cold, that they know completely, in order for them to pass the class, say to get a C, okay? So I would think of those as like the core standards for your course. Okay. And maybe, you know, in principle, when a syllabus goes through the curriculum committee, there's student learning outcomes and all this stuff. But for a course like calculus that went through the curriculum committee, you know, 100 years ago, those things have not been revised. And so you might have to actually stop and think about, first of all, what are your student learning outcomes? And that is a good place to start. What do you think students should know? But even those tend to be a bit broad. So I've thrown an example up here of this is just calculus 1. This is what I know, and we'll talk about other things later. So I have 10 core standards for calculus 1. Okay, these are the 10 things that I think students should be able to do. And if it's been a while since you've taken calculus, this doesn't matter. Just know that these are fundamental that you would have to know. So can you compute limits? Do you know what continuity means? Can you take derivatives of common functions? Do you know the product and quotient rules? Do you know L'Hopital's rule? Can you find local extrema functions? Do you know the fundamental theorem of calculus? One assumes, right, you would hope, that students who pass calculus could stay with the fundamental theorem of calculus is, okay? And so these are 10 core standards. So without getting into a lot of nuts and bolts yet, in order for a student to get a C in the class, they have to demonstrate that they can master these. That's just a bare minimum. And there's more that goes with it, but this is the absolute bare minimum. And this is nice because it sort of says, look, if you can't do these basic things, you cannot pass this class. Because if I pass you, you're just going to fail the next one. You know, this is really fundamental stuff. That's great. That's for sort of setting the stage. But then you might ask, okay, now what about advanced standards? Okay, are there more sophisticated things that we expect them to do? So, come on, wake up. It goes. So now I have some advanced standards. Now I have 15 advanced standards in this course, which you always get ambitious, and 2/3 of the way through the semester you start to regret having quite so many standards. And there's some redundancy here too. So these are the more sophisticated things that might go along with Calculus 1. So more difficult sorts of limits, indeterminate forms of certain types of limits. The definition of the derivative, which students forget immediately. Right. Trickier differentiation stuff. Related rates, that's a fundamental application. Sketching curves, sketching, you take the function, you can sketch the curve in terms of things. Optimization problems, that's sort of the fundamental application of differential calculus. Antiderivatives, Riemann sums, integrals, and things like that. Substitution method, evaluating simple integrals. So these are sort of the advanced standards. Now, maybe students aren't going to some students will master all of these. They get an A, right? Some students won't. And so, I'll show you some sort of actual a rubric for how I give a student a grade under this scheme in a minute. But this is really nice with students. It's really nice to do this. When you assess these things, you give them a little quiz or whatever, and either they master it or they don't. And you can decide, oh, this sign error doesn't matter, or whatever. But if they've mastered it, great. Check it off. If they don't, you're no longer arguing about points. I mean, how many of you have given a test, right? And afterwards they come to you and go, well, why did you only give me 3 points here? Why can't I have 5 points? You argue about points. What's a point? You're arguing about meaningless things. They're just these tokens that don't matter. And so what happens this way is you have these assessments and you grade them, and you can make comments or whatever, but then you find out that when the students come to ask you about them, you're actually talking about the material. You're not talking about the grade. Because you said, look, you didn't master this concept. Why didn't you? Let's talk about that. How can you fix this moving forward? Okay? It's not an all or nothing thing. Okay? You have to let students reassess. It's not just, hey, here's your one chance to prove that you know this concept. They do it. If they don't master it, they can do it again. Okay? Now, how many times? That's a story for later, but that's something else. By the way, I also insist that they take a final exam. And just pass it. Just pass the exam, 60%. And then whatever they did with under the mastery scheme, that's fine. They have to demonstrate they passed the test. That's sort of a university requirement, right? In courses like this, we have to give some sort of final. So okay, fine. And although I have had to be lenient about that too. So here's the grading scheme for this course. What's really nice about this is, okay, so to make an A, so you have to master all the core standards. That was the 10 things. There are 15 advanced standards. They have to master 12 of them to make an A. But of those 12, I insist, if they want an A instead of an A-, that 2 of them include these 2 major applications. Okay, so this is even better. This is where you get to the finer gradations. You say, okay, you want an A, you have to prove that you can do these 2 fundamental applications of the course. If not, you can still make an A-, that's fine. But if you can't demonstrate that you know how to solve applied optimization problems, you cannot make an A in the class. I keep track of class participation. It's basically showing up if they're there. And then, and I do assign homework. In the past, we used WebAssign for online homework. The math department is piloting a new homegrown online homework system called Kronos that is, we've got the college to pay for TAs to do it, and it's free for our students and works better, actually. So we're doing that. So they have to do their homework well. To get a B, again, you have to master all the core, 10 of the advanced, and then certain thresholds. To get a C, you have to master 8 of the advanced. D, well, let's not talk about D's and E's. The truth is, I I've given 1 E under this scheme, and usually students drop before they think they're going to make an E, let's be honest. But I had one student who was convinced she wasn't going to make an E, and then she did. I don't think I've ever given a D, right? Nobody sticks around for that. And I've given very few Cs. I mostly give A's and B's because they have so many opportunities to demonstrate how this works. So,
I have a question.
yeah.
What if the homework score is 65, but
Oh,
the
yeah,
participation score is 80?
Yeah. The students always ask about that.
Yeah.
And my answer is, don't worry about it. Because again, right, so the question is, yeah, so say somebody's homework grade was only an 85 or
Because some
something.
people can just do it.
Right. I never held these things against anybody. If they mastered the standards and they made a good faith effort at their homework, and like they didn't not do it or they didn't have a 50 or something.
What if they never come to class and never did homework and magically got it?
I don't know.
Seems unlikely.
Oh no, we have those students. I bet 100 students in my current class are that way. Because on the first day of class, I asked, how many of you have taken calculus before?
Yeah.
All of them have taken it before, basically. So
And it kind of does seem unfair to punish them if they already know the material.
that's right. So actually, like I said, I've never actually held that against anybody. That's a personal judgment thing. But what I've discovered is, I was doing this in the context of a flipped classroom too. So, the students actually kind of wanted. Didn't you guys want to come? Wasn't it fun to be in class with me?
You're talking to the wrong crowd.
No, of course, students didn't show up sometimes, but it was, participation and all that was never really a problem. Students want to make sure that they're not going to be punished, so it was never really much of a problem. So, just for fun, I thought I would show what an assessment looks like. So here's the applied optimization assessment, and it's 2 problems. That's it. Some of you can probably do this. Farmer wants to make a fence an area of 1.5 million square feet in a rectangular field and divide it in half with a fence parallel to one of the sides. How to do this to minimize the cost of the fence, right? So you want to minimize your fence, okay? That's one problem, and then, and then the second problem is you want to make a box with a square base and an open top and a certain volume, find the dimensions that minimize the amount of material used, kind of the same kind of question. And these are very typical. These are not difficult, right? These are just sort of mid-level questions that you might ask. And what's nice is, the student has to they have to get both of these completely correct, little arithmetic errors, I don't care, but just, conceptually, completely correct. And if not, then they can try again. But what's nice is if you think about how an ordinary grading scheme would work over the course of a semester, this takes place in the sort of late 3rd quarter of the course. So this might show up on exam number 3 or whatever. That's the one chance where they can do it, and who knows if they get it right or not. You don't know because all you see is a number after the fact. And then, yeah, there's probably one on the final exam, but again, it would be a multiple choice thing on the final exam. So you're not going to study 600 scores to see who got that question right. So student might make an A, you have no idea whether or not they can do these, what are really fundamental sorts of questions that we expect our students to be able to solve coming out of this course. So now, if they get one right but not the other, what do? I insisted it's all or nothing. Now, students might argue about this one, and I'll ask them later. But sometimes they will get one right and not the other, and they have to do the whole thing again. And this is just, this was number 1. Okay, so I have multiple versions of this. So the next one is not the same. It's like, you don't get to do the same ones over and over. And so the next one, well, those problems were harder. No, they weren't. They were just different. Okay, so we can talk about other schemes to do that too.
So do students do this in their discussion sections, or what's
Yeah.
the format for?
Yeah. So I'll say one word about that now, and I'll talk about more nuts and bolts later. Yes, because we have discussion section 1 day a week. Sometimes I would do them in class if I felt like we sort of had some padding in the schedule. as you discover that they need more and more opportunities, I would schedule evening times when the other classes, when the regular classes were taking ordinary exams. And we call them assessment fests. And they could take, I mean, boy, they'd show up and they'd do 10 of them, you know. So that's sort of the basic nuts and bolts. I've asked a couple of former students to come today to sort of give you their impression. So we have Maria in the white shirt and Diala in the black shirt. Guys, I don't know which one of you wants to go first, but so just sort of generally, A, how did you like this? B, do you think you learned more? C, what was wrong with it? D, yep.
I actually took Calculus 1 my freshman year fall semester, and it wasn't standard-based grading, it was regular. And I personally have a really bad testing anxiety. A bunch of other students do. It's really normal. And as the Calculus 1 class went on, I did well in the first exam, and then as the test went on, I just didn't do as well. And I didn't really understand why, because I would spend day and night studying for them. And my advisor at the time used to tell me, like, don't let this, like, define who you are as a person, but, like, how could you not when you study so hard and you don't do well? So I ended up not passing that time, and then second semester during the spring, I got lucky, and I just, like, randomly picked Dr. Knudson's class. And it was probably the best experience when it comes to calculus, because I don't really know how to explain it. It was just like, you're forced to go back and look at the things that you didn't do well on before and pass them. Because before, in the other exams, you would not pass it and be like, oh, okay, well, I don't really know what, I don't get the test back, I can't look at it.
Hi everybody, my name is Maria. I'm a third year biomedical engineering student. I actually had Dr. Knudson, so 2 years ago, I had him for Calc 1 and Calc 2. So our first semester, we had, since I guess like you say, we were like, my class was the guinea pigs of this standards-based grading. And we were running both types of classes at the same time. And so we had to take every single exam that the bigger class would have to take, and we had to take the final, and then basically in the end, whichever grade was higher, he would take that grade. The exams that like the big class takes are pretty difficult. Like even if you study, you can know all your things, and like she says, everybody has test anxiety, everybody has bad days, everybody has these things where they can just make a little mistake, and it's only 14 questions, those tests. You make 2 mistakes and that's already like a B. And that's frustrating as a student. But with the standard-based grading, you find yourself actually like focusing on topics and learning the actual topics instead of, oh, that's not going to be in the exam, I don't care. I've said that so many times. Why do I care it's not going to be an exam? Because that defines, like I wish as a student that I wouldn't necessarily care about the points, about the grade. Every teacher says it doesn't matter what grade you get, but it does. I'm trying to go to med school in a couple of years, your grades matter. They always do. And so it's really nice to have a system like this where you can learn and you can get the grade that you actually really do deserve, because like he says, if you can't master all those standards and the advanced standards, you shouldn't get an A anyways. And like he said, there's a lot of padding in the big classes. You never know how people get A's, they can cheat, they can do whatever, and that's not fair for students who study and students who actually learn the material. For me, like that was the part that I liked the most about the standards-based grading, the fact that I was like actually learning, and the fact that I wouldn't forget it 2 days after the test. Because we've all been there, we've crammed for tests, and then 2 days later, I don't even know what l'hôpital is. But the fact that you actually have to like really pay attention to the topic and really pay attention to all the different types of questions that they're going to ask you, it helps you learn the material a lot better, and it helps you not forget it.
In the beginning of the presentation, when all the standards were up there, we were looking at them like, wow, I can't believe like we've actually like did all that. It seems so easy now. It's actually like it stays in your brain, because you're forced to go back and just you have to master it. If not, you don't pass the class. You have to go back and keep practicing the same problems over and over again, and that obviously is going to get stuck in your brain.
Yeah, I mean, like no matter what, obviously, depending on how long it's been since you've seen something, you might not immediately remember how it is, but like. Yeah. Maybe I'll see like Newtonian method, and I'm like, oh, what is that? And then I read the little description, I'm like, oh, I remember. And like, you might not be like, yeah, I can master a quiz right now, but you definitely have a really good foundation on each topic, I think.